Welcome to C programming. This lecture is to discuss about selection sort. In selection sort, we'll select the smallest element in the given array and we'll swap it with the first element of the array. And then the second next smallest element is selected from the remaining elements, that is from the unsorted array, and is placed in the first position of the unsorted array. That means the array is divided into two parts. First is sorted part, another one is unsorted part. Initially, the sorted part of the array is empty and unsorted part is the given array. The sorted part is placed at the left side while unsorted part is placed at the right. So for example, we take the array. In this array, the index is given on the top, that is index equal to 0th element is 45 and first element is 20 and so on. In this, the whole array is unsorted. So we'll select the smallest element in this, that is 5. So we'll swap this element with the 45. The 5 is swapped with 45. So the rearranged array is like this. 5 comes into the first place and then 45 comes here. These two are swapped. So we have got two parts of the array now. One is sorted array, which has only 5, and unsorted array, which has the remaining elements on the right side. Now in the remaining elements of the array, that is unsorted array, we'll again select the smallest one. So we'll again select the smallest one, that is 15. Now the 15 is swapped with the first element of the unsorted array. First element of the unsorted array is 20. So this 15 is swapped with the 20. So we'll now get the sorted array with the elements 5 and 15, and unsorted array is the remaining one. Again, we'll select the smallest one in the unsorted array. So that is 20. Now the 20 is swapped with the first element of the unsorted array. So first element of the unsorted array is 40. So we'll swap 20 and 40. Now this sorted array consists of 5, 15 and 20. And in the remaining unsorted array, we have the smallest element as 25. So this 25 is swapped with the first element of the unsorted array, that is 45. So 25 and 45 are swapped. Now we'll get the sorted array as this, and unsorted arrays having 40, 40, 45 and 50. In this, smallest element is 40, which is at the first place of unsorted unsorted array itself. Therefore, no need to swap it. So 40 itself is the smallest one. So swapping is not required. And then the remaining unsorted elements, that is 45 and 50. 45 is the smallest and which is in the right place, so swapping is not required. Now the whole array is sorted. This we can write an algorithm and then a program. So in the selection sort algorithm, first we'll get the size of the array and the array elements. So the same thing we can do it in program. So enter the number of elements, the size of the element, size of the array, and the array elements with the for loop. So initially what we'll do is we'll pick one element from the unsorted array to be replaced with smallest one. So we'll take first I equal to 0. That is, we use for loop for this, for I from 0 to size minus 1. So that means we'll take first 0th element, then first element, then second element, and so on. We'll replace each element by the smallest one of unsorted elements. So that is why we write a for loop for this, and then we'll set I as the index of the current minimum. So we assume that the 0th element itself is the smallest element first. And if anything other than this is found as smallest, we'll modify this minimum as that. So minimum is equal to I means minimum equal to I equal to 0 means 0th element is assumed to be smallest right now as current minimum. And now for j equal to I plus 1, and from the remaining unsorted elements, we'll compare whether it is less than minimum or greater than minimum. That is, if array of j means the first j equal to now 1. If array of j, that is array of 1, is less than array of minimum, that is array of 0, then what we say that if this is true, that means array of 1 is minimum. So that means minimum value is found at position 1. Now we'll modify that minimum as j. So this for loop continues until it finds the smallest one of all the elements. So j iterates from j equal to I plus 1 to j less than size. So why j equal to I plus 1? Because the unsorted array starts from ith element. We assume that ith element as minimum. So therefore, we compare this with the remaining elements, that is from I plus 1 to size minus 1. And if any minimum is found, then we'll modify this minimum element as that element from this range. Therefore, we take j equal to I plus 1, j less than size. Uh, if current minimum is not I, if current minimum is the first the ith element itself, then we need not to swap it. If it is not so, that means the smallest element is somewhere in the unsorted array, not the first element of the unsorted array, then we can swap it like this. That is, temp is equal to the ith element, and then ith element is now empty. In the ith element, we'll put the smallest element, that is, the smallest element is pushed into the first place of unsorted array, and in the smallest element position we'll put the temp, that is ith element. So this process is continued till all the elements are getting sorted. This is the end of the selection sort. Now we can check the program. First we'll access the size of the array and then array elements. For that, let us say size of the array is this. Print enter the number of elements or size of the array, and then we'll enter the array elements using for loop. Number of elements required are equal to the size. So enter percentage integers size for I equal to 0, I less than size, I plus plus. We will use a scanf statement to read the array. So that is scanf percentage d ampersand array of I. So each element is read from the user keyboard. Now once you get the size and array elements, now we can write the program for this selection sort. For I equal to 0, I less than size, I plus plus. So ith element needs to be replaced with the minimum smallest one. So that's why we are writing the for loop. So each element selected as I has to be replaced with the smallest one. Now first we'll assume that the smallest one minimum equal to 0th element, that is I, and then for finding the smallest one in the unsorted array, let us take another for loop for j equal to I plus 1, because the minimum is found from the remaining unsorted array j equal to I plus 1, j less than size, j plus plus. Now we'll check whether this smallest one is ith element or anything else. That is, if array of j is less than array of minimum, we assume that ith element is minimum, but we'll compare each and every element with that minimum element. Array of j is then array of minimum, then we can say that minimum equal to j, because we are modifying minimum as j, because we found that array of j is less than array of minimum. So once this is done, this loop will continue to find the smallest one in the unsorted array. So once smallest one is found, we'll check whether the minimum is right now I or not. if minimum is not equal to I, if minimum is equal to I, swapping is not required because this ith element is the first element of the unsorted array. If ith element is not the minimum, jth element must be minimum, so we need swapping. So swapping is done like this. First we'll take a temp variable. So temp is equal to array of I. We'll put the ith element into temp, and now array of minimum equal to, so temp equal to array of I. So that means ith element is stored in temp. Now the array of I is empty. In array of I we'll put array of minimum. That means minimum element, smallest element is pushed into ith position, and then in minimum is empty. Now in minimum position we'll put ith element. Ith element is now stored in temp. So array of minimum equal to temp. So this completes the swapping. Once the swapping is done, we can print the array. Swapping is done, and also this each element is swapped. So we'll put a floor bracket here to for the outer for loop, and now print the array. So to print the array, we know we'll write a for loop here. Print sorted list in the ascending order. For I equal to 0, I less than size, I plus plus, printf %ld. This instead of slash d, you can put two spaces, array of I. Now we'll check the output. Now let us check the output. Enter the size of the array, 5 elements, 5 integers, 6, 2, 1, 3, 4. So we got the sorted list as 1, 2, 3, 4, 6. So this is the selection sort. Thank you.